And our final speaker in the morning session, coming from Paris, Peter Bancel. Peter is from the Institut Métapsychique International in Paris, France, and he's going to be talking about detecting Psi-Missing in forced choice data, although I think the title of his presentation might have changed a little bit, but Peter will tell us more in a minute.
I want to thank the organizers for making this possible. It's really great. It's nice to be here in Oslo. I have family in Oslo too, so that's especially nice for me. One of the things that's interesting about giving a talk in the first morning session is it gives you a really nice perspective on what jet lag is really like. So that's sort of where I'm starting from. And I'm also, this is a nice context, I think, the previous two talks, because in this session we're looking at data, and that's what I want to talk about is data, but in particular, how we look at data. So I'm not going to give a very technical talk. My abstract was a little bit kind of statistical and stuff, but I want to just step way back and just make basically a couple of comments on how we look at our data, how we analyze it, and the mistakes that we can make, and also some ways that we can get more out of the data than we might normally do. My training was in experimental physics, and so I like data. I like doing experiments. The reason I like experiments is because you get data, and from that little box of experimentalist, data is the most precious thing you can have, so you really like it. But what makes data precious is how you treat it. So I just want to make a couple of comments here on that. And I'm going to do it in the context of what we call Psi-Missing. So this Psi-Missing, I'm going to assume that people know what that's about. It's basically when we do an experiment that has some kind of direction to it. Like, for example, you want to get something to move up in the air, like levitate or something, then Psi-Missing might be if it goes down through the floor, something like that, something that's the opposite of your intention. And I come to this actually from when I first got into Psi research. I was doing experiments in physics, and I went to the PMIR lab in Princeton University many years ago because I was interested in the work that they were doing there, and they let me come in and sort of do a replication of one of their classics experiments, which is a PK experiment with RNGs, with random number generators, in which they have a participant or a subject sit with a random number generator that's putting out basically a stream of bits of ones and zeros, and they ask the subject to try to, through a psi effect, just by intention, have the random number generator produce more ones than zeros, for example. And surprisingly, they got an effect, and that was how I got into Psi research. So I went there and I replicated their experiment. I did a particular experiment myself where I selected meditators for the subjects, but it was basically just the same experiment that they were doing at the PMIR lab. And I didn't have a big enough database to really get an effect like they did, but what I did reproduce, which is actually why I decided to continue with research, and I'm looking for is there a pointer? It's here? Is this it? No, that's a mouse. Is this it?
You got it.
Oh, okay. I thought that was for the music. No, okay. All right. Okay. Is this?
Press the top one.
The top one. Okay.
There you go.
Great. So this was an interesting effect that they saw in the PAIR data, where they would have people come into the lab and do multiple sessions. Somebody would come in one day, and then they would come in and do another session, and then they would do another session. And what they found was that on average for their subjects is that they would start out with some effect, So this measures the effect, and here a zero effect would be a dot on this line. And then as they go on through a second session, a third session, the effect goes away and then goes negative, so they're getting psi-missing by the time they get to the third session, and then it bounces back. And that's such a particular kind of, I mean, you can make up psychological reasons why that would happen, but it's such a particular kind of effect, so that I analyzed it in the own data that I had, which was overall not significant, but I found this same effect in my data, and in fact, much stronger than it was here. So the meditators were kind of doing the same thing as the people in Princeton were doing, but even in a stronger way. And it's driven by this psi-missing. So when I saw this, I had two reactions. One was, actually, there's something really going on here that I was replicating, and so I was very interested to continue. But what I was really focused on was I wanted to get an effect. And so I kind of ignored the psi-missing as something to really, really look into. And that was a mistake. So my first point is that we really have to keep our eyes open when we're looking at the data and not miss something. Because if you blink, there might be something really interesting in the data that is trying to tell you something. And the second thing is that in this particular case of psi-missing, psi-missing is psi. Psi-missing is a real effect. So we don't want to throw that baby out with the bathwater. Now, this notion of how you look at data and how you then looking at the data, but also analyzing the data, is very, very important to the current situation in science altogether. Jürgen made a reference to this replication crisis in science, where there are a lot of effects that are found, and then when we try and replicate them, we aren't able to do it. So this is something that you find not only in parapsychology, of course, but in psychology and economics and medical research across the board, where there is data that is being analyzed to show statistical evidence for effects. So the replication crisis is a real thing. It has to do with methodologies and other things. But in some way, it's a statistical crisis. Okay, so it behooves us to think a little bit more about how we are treating our statistical data. But also, I'd just like to point this out, that, because particularly from the point of view of a physicist, when you're doing data that's generated from work with humans, it's actually really difficult to do those kind of experiments. So whether, and to get consistent results. So whether it's sociology or economics or psychology or parapsychology, working with data generated from human beings is challenging. But when it comes to psi effects, then, it's sort of challenging to the squared. It's even more challenging. So just a note on sort of like to dive down a little bit into what that challenge is. So here's a little schematic of, how you might say how science works. So basically it's an interplay between theory, ideas, and experiment, data, and it circulates around, right? And so a more detailed way is you start out with something theoretical, you make an experiment, and from that you generate some data that's going to give you some statistics. So this might be something like, for example, I have an idea that psi effects are associated with unconscious states that are very charged emotionally, and that these kind of states can correlate with things that happen that are measurable physically, okay? So that's kind of a theoretical notion, and then I can take that theoretical sort of hypothesis and make it into an experimental one where I say, okay, well, the way I'm going to do that is something like what Jürgen shows. I'll show different stimuli to people, and I'll couple that stimuli to maybe something physical like the output of a random number generator, and that's how I'll do an experiment. So that's my experimental hypothesis, is that there should be something happening there. And then that generates a statistical hypothesis where I say, well, the way I'm going to actually analyze this experiment is by looking at the average number of bits that my random number generator puts out. So there's these different hypotheses that you make, and that's how you get the data. And then once you have the data, you just go back up the chain. So you're going to make some inferences from the data that you see. So there'll be a statistical inference about, did I really see a difference in the outputs of the random number generators under two different conditions? And then from that, you want to make an inference as to whether or not it really addresses the experimental question, and then whether that can get back up to your theoretical idea. And so in this chain here, in making these different inferences, those are all the places where we can go wrong. Right? So we can make errors. In particular, we can make errors in our statistical inferences, which is kind of at the level of analysis. So this is actually really a problem in science. This is a paper that's quite interesting and also quite recent in Nature, that is addressing how scientists in all fields actually go about doing this loop of inference. And they're making a big pitch for what we really need to do is to make things as absolutely transparent as possible, so that the people who are doing the experiment and the analysis, that they can see what they're doing, and also so that other people who are going to look at their research and read their paper, they can see what's going on. So we don't want tables and charts. We want to have some way to actually be transparent and see, and they list a number of things to do, and the very first one on their list is to just visualize the data. So this thing of seeing, and it sounds like so sort of simple and trivial, but it actually can have really big consequences if you get good at doing that. So here's an example of that, and if anybody has ever taken a statistics class or something, you've probably seen this example of how correlation measures can go wrong. So these are 4 different data sets, and you can see that there's very different things going on. This data set is very different from this one. But all of these data sets show the same linear Pearson correlation. So if you're just going to say, oh, I'm going to measure a correlation between 2 things, and you get a big value, this is a really strong correlation, a value of 0.8. But unless you know how to actually visualize the data, you might miss something really important. So when we think of correlation, we usually think of something like this, something scattering about a line. But look over here. This is the same linear correlation, but obviously the data are not linear. There's actually a perfect 100% quadratic correlation in those data, right? So this is really important, and it's particularly important because this is the mistake we make in parapsychology all the time. Okay, so I'm going to give you a couple of examples where we've made really big mistakes. So one example here that I've looked at a lot very carefully is the Global Consciousness Project. Now, I don't have a lot of time to go into this, but probably have people heard of that? So the Global Consciousness, yeah, most everybody's heard of that. Great. So what the Global Consciousness Project does is it looks at random outputs of random number generators and how they correlate. So they have their network that's spread around the world, and they measure the data, and they see that there's correlations amongst the RNGs for certain times that are associated with certain events in the world that are important, that the project identifies. And what they can do is they can kind of add up how much correlation you see at those times. And that's what this is the globe in the dark here. That's the global consciousness data for all of their events over the course of the events. And they see a huge effect. It goes up, up, up. And so that is taken as it's clearly a strong statistical effect, and their inference is that it proves their hypothesis because it was generated through the experiment that posits the hypothesis. But a problem here is that what you want to do if you have data like this is you want to look at all the data. and see, is all the data consistent with what I'm hypothesizing? And what you would expect for this kind of effect is that there would be nothing, then it would turn on, and then after a while it would turn off. So there's an important World Cup football game or something, and it has this place it starts, and the effect starts, and then it ends, everybody goes home, and the effect turns off, and you should see some kind of S-curve like this. So the question is what do you see in these other places? And actually, if you really look at the data, so this is the real data, you see nothing at all like this. So this actually completely refutes the hypothesis, but you don't see it unless you visualize the data correctly, okay? And so it's kind of mirroring, what we were showing with the correlations over here. If you just look at a little bit of the data here, you might think it looks like this, but then if you actually reveal things, you can see, oh, something very different is happening. And so this kind of thing happens in parapsychology a lot. It happens in science a lot. And so this is just a kind of a publicity for we should be very careful first to have a good visualization of our data. There are other examples in parapsychology. There's a famous experiment that came from the PEAR lab where they missed outliers, and that had serious consequences. If people know about Jürgen, you probably know about the replication that was done with IgGP and the PEAR lab and all. And there was a mistake that was made because outliers were not taken into account. But if you visualize their data, it jumps out at you. You can see that. There's another example that has to do with general micro PK. All these experiments with random number generators, where if you do meta-analyses, and you don't look at all the data, or you don't properly take into consideration all the data, you can run into trouble. So I won't go into this, but it's just another example, and I could cite others, where some proper visualization would help. Okay, so suppose you do visualize your data, and you see something that needs to be investigated, then what's the next step? The next step is that you want to have a way so that you could test for the data statistically based on what you've visualized. And that's what I want to talk about in terms of Psi-Missing. And so this is a more recent experiment that I've done where I've encountered the Psi-Missing again. So what do I show here? These are data of just a binary guessing game, a psychic guessing game, data where you would get a hit or a miss. And the red curve is what would happen if it was a null experiment and there was no psi happening at all. And the black curve is the data that I get. And when I did this experiment, I was expecting to find a hitting psi effect where the average would go in the direction of people trying to get the effect. And I got basically no effect, a very small effect that was insignificant. But when I visualized the data, what I saw was that actually there was something going on, is that some people were hitting, but other people were missing. And the two were canceling out, right? And so if you visualize it, you can see it. Right? You can see it. So it's actually a little tip about statistics. If you can see it, it's a big effect. Okay? It's like you don't need to run it through a neural network. You can just see it with your eye. That's your neural network. So the question is if you have something like this, then how would you go about detecting that, right? And so I'm not going to go through the details because they're gruesome, but what you need to do if you are aware of something like this happening is you have to say, okay, what is the best general kind of statistical test then that I can make in order to detect something like this? And what is this effect here? The effect is actually a mixed effect, isn't it? I'm getting some psi that's going in one direction, the hitting, and I'm also getting some psi in the other direction, the missing, so I'm mixing two effects together. So then how do you detect something if you have a mixture like that? And you can think about it, and I've thought about this a lot, and you can come up with different statistical devices, tests, to see if you can detect this sort of thing. And the real point is that once you start to do that, you have to really go ahead and do the work to really understand what your tests are, what are their powers, what is the best way to formulate them. And that takes a lot of work, a lot of computer work, a lot of simulations and stuff like that. But it's all being driven by the fact that you started with a visualization that was helpful in the first place. Another thing that happens once you sort of go down this road is you can discover more subtleties to the problem that you have in front of you. So let me just show you that, and then I'll kind of close with that. So what I show here, I'm imagining here that this top row here is an experimental session. And each little dot is a trial in the session. So somebody's sitting down for the experiment and they're doing 10 or 20 trials. And the person, number one, is getting a lot of hits. That's the green dots. But then somebody else comes along and they're doing psi as well, but they're missing. And so I can get these two effects, and in all of my database, they're all mixed together, so I have to figure out how to detect that. But there's another kind of thing that can happen if you think about it a minute, and that is, suppose that someone sits down and they're missing, they're doing psi-missing for a while, but then all of a sudden they kind of get their mojo. They kind of, they click in, and then they start getting hitting. Or maybe it goes the other way. Somebody is getting very, very good success, and then they get nervous, and the whole thing kind of falls apart, and so much so that they start to do missing. So this is a much more complicated thing. And the kind of statistics that you could do on the first case don't work for this one. So you have to be able to realize that there's different ways that this very basic mixture of hitting and missing could arise, and you have to adapt your tests also for that. So there is a way to do this, and I won't bother too much with the details, but it's called an autocorrelation, is something that will detect this kind of thing very well. So you could have a situation where you're having a mixing of people who are very good at hitting, very good at missing, and you can detect it quite easily. Or people might go first one way, then the other way, first one way, then the other way. And the straightforward kind of tests, I'll give a name to them. You can test for the variance, you can test for the skewness or the kurtosis, things like that. Those don't work. But what would work, perhaps, would be the autocorrelation. And in fact, here in this plot, I show the orange line is what the autocorrelation looks if there's no effect at all. It's just completely random data. But if you get this kind of first hitting, then missing inside a session, you see a very strong autocorrelation effect, and you can test for that. Okay? So all of this comes from first visualizing the data well, and then saying, oh, wait a minute, I have to go deeper, and then modeling how these mixture effects might happen, okay? And running through the tests, understanding them, doing power analyses so that you can come up with some kind of test that will allow you to reveal psi even if it's trying to hide from you. So let me just close. I'm going to give a talk on Sunday where I'll show an experiment a little more where we've used some of these tests. But to close, let me go back to the beginning 20 years ago when I was replicating the pair lab with meditators. And I saw this sort of down-up effect. It was actually only after thinking about Psi-Missing more recently, in the last year or two, that I realized, oh, I should have applied that 20 years ago to the replication I did at the PEAR lab. And the first step would be to visualize this better. So I went back to those data and I dug them out and I looked at all the data instead of just these sort of chopping them up into the first sessions that people did and then the second time they came into the lab. I actually took all the data and put it all together, and it gives a curve that I think this will go away in a minute. So you can see that if I had thought to visualize these data better, what I would have seen was this amazing effect in these early data where, so what is this? In this whole experiment, I had about 20 people, right? And the people, everybody did like 4 or 5 sessions. And each session was an hour or hour and a half. They were meditators, so they could do that. They could sit there for a long time. And it had this amazing thing where the data went way up, and then everybody was getting hitting, and then everybody was getting missing, right? And it ended up here, which is an insignificant 1 sigma effect. But if you look at this, you say, oh, something is definitely going on there. And if I use this, for example, this autocorrelation measure on these data, which were created 20 years ago, then I see that there was actually a strong effect. So visualizing in this way and then thinking about what you see when you visualize is very, very sort of basic way to approach the data. And we don't do it thoroughly enough. And we should get better at that because there's maybe things in the data that we're missing. So thank you very much.
Okay. Thanks very much, Peter. If I may ask just the first question, and then we still have about 5 minutes, so we can get more questions. Can this method work prospectively, or do you have to have your data already collected, then visualize it, then see whether or not there's hidden psi in your data? Or is it possible to predict for a new data set where to find your psi?
My sense is you need the data, right? But you certainly can, and that's sort of what I did with the autocorrelation, is imagine what are different ways that this general effect could arise and then simulate it, right? So maybe you can do both with simulate.
There's a question over here.
Yeah. Thanks. Very nice talk, and I'm so happy that I showed the data. Yeah. So, quick question. So, I mean, your method, which I could completely follow, somehow contradicts the pre-registration idea, right?
No, not at all, really.
I mean, then it's different, right? It has to do with, I mean, if you do pre-register, then you have to follow what your registration was, right? Yeah, for sure. But you always want to learn from your data, right? Yeah. And there is something else about even if you pre-register, you can still, and I'm sorry, this light is just like right in my eyes, and you're right behind the light. So, and this was the point of this paper by Wagenmakers. You know Wagenmakers, right? Yeah, he's a very famous statistician who's worked a lot on the problem of replication and everything. And he says, you know, even if you're going to pre-register, you can still make a good visualization of the data so that other people can see the data. So maybe it doesn't fit with what maybe you're going to be sorry that you didn't think of something when you pre-registered, but make the data transparent and lucid for everybody.
or we simply may follow the pre-registration and do additionally exploratory.
Yeah, or do an
step
exploratory thing.
on top of
yeah.
it, right?
But make it all transparent so that everybody can see it, super easily. Yeah.
Thanks.
Right. Okay.
Thanks so much, Peter. I know you've thought about Psi-Missing probably more than many of us in this room. What do you think is actually underlying that, what we're seeing with Psi-Missing? What is it?
Fear and frustration.
Fear and frustration?
That's what I think.
Okay.
That's what I think.
Okay.
Yeah. But who knows?
The data you showed was from random number generators, right?
So which data?
The loss curve. When you look back to the peer lab.
Oh yes,
methods.
yeah,
Yeah.
right. Yeah, that was the standard pair protocol.
Yeah, so the random number generators produce zeros and ones, and the person is going to predict zeros and ones, right? So the data are zeros and ones
Yeah.
that the person should.
No, it's not a prediction. In the pair protocol, what they have a continuous stream of output from the random number generator, and the participant is seeing in feedback what the random output is, and they're asked to hold an intention that it would drift in one direction and then in the other direction.
Sort of PK effect.
Yes.
Yeah. Okay.
Yeah.
Suppose there are some physics here that if you could produce a set of zeros, then afterward there will be a set of ones, or the other way around. That the physics says that it should equal out in the long term. Then what you could see might be a physical effect of the PK, that you have an effect, but the physics drives it back to meet.
Oh, this is like Fotini's thing? Is that what you're thinking? The Policari thing?
No, sorry, I didn't get that.
Huh?
I don't understand the term you used.
Oh, there was a proposal for something like this balancing effect. Is that-
Yeah, I'm proposing a balancing effect.
Yeah. Two things. First of all, you can't assume that if the data are deviating from the null distribution, you can't assume from the mere fact of deviation that it's actually a PK effect. There are other ways to get effects. You can have a biased selection, sort of like when you start that's what's happening in the Global Consciousness Project. It's not a PK effect, it's a selection effect that happens. So you have to have some kind of statistical way of knowing is it PK or not, right? And then if it is, so let's imagine that it is PK, then could there be a balancing effect? I suppose there could be. I think it's very unlikely because what it means is that somehow nature knows about the experiment that you're running, and nature cares about your direction of up and down, and also what your data was 5 minutes ago. And I find that to be even more bizarre than psi effects. And also, the most well-known proposal for this kind of balancing was by Fotini Policari. And she's a solid-state physicist, and it's something that's very natural in solid-state physics to see that systems that are driven from equilibrium find their way back to equilibrium. But that's in a coupled system where you have interactions with some kind of other, moderating environment. And I just don't see that happening in Psi. So I am very skeptical of the whole balancing idea. But that's my personal take.
All right, it's nearly lunchtime, so we do wait a minute because we do have announcements, but for the moment, thank you very much, Peter.